On November 5, 2025, we received a message from the void, not in words, but in the cold, hard light of data. Two new images of the interstellar object 3I Atlas were released, and they have thrown open a Pandora's box of questions that strike at the very heart of our place in the universe. We are now confronted with a cascade of anomalies, from an impossible trajectory and a physics-defying propulsion system to a chemical makeup that looks more engineered than natural. This is the story of an object that should be shedding billions of tons of matter, yet remains mysteriously clean. It is the story of an impossible acceleration that has no visible cause. This December, as this enigmatic visitor makes its closest approach, we stand at a precipice. We will either solve one of the most baffling cosmic puzzles we have ever faced, or we will be forced to confront a reality we have only ever dreamed of, and perhaps feared. Is Atlas a fluke of nature, a one-in-a-trillion celestial weirdo? Or is it something else? Something more? Join me as we unravel the data, explore the dramatic theories, and count down to the moment humanity may find out, once and for all, if we are truly alone in the universe. Imagine the scene in observatories around the world on November 5th. The anticipation is electric. For months, the scientific community has been buzzing about 3I Atlas, the third interstellar object ever detected, and a giant at that. Its trajectory has already been flagged as unusual. Now, the Virtual Telescope Project, a state-of-the-art robotic system that allows astronomers from across the globe to peer into the heavens, is about to release the latest, sharpest images. Everyone expects to see one thing: a comet. A big one, sure, an interstellar one, even rarer, but a comet nonetheless. And what does a comet look like when it gets close to a star? We all know the images from textbooks and NASA's website. It's a dirty snowball, a relic from the dawn of a star system, composed of ice, dust, and rock. As it swings in from the cold, deep freeze of space and feels the warmth of a sun, that ice doesn't melt into water. It sublimates, turning directly from a solid into a gas. This process, known as outgassing, creates a vast, glowing atmosphere around the comet's core, called a coma. The sun as solar wind and the pressure from its radiation then push this cloud of gas and dust away, forming the iconic, ethereal tail that can stretch for millions of miles. Think of it like a piece of dry ice on a warm sidewalk, continuously shrouded in a fog of its own making. This isn't just a possible feature. It's the defining characteristic of a comet. It's its signature. So the data from the Virtual Telescope Project streams in. Astronomers lean closer to their screens, ready to analyze the coma, to measure the tail, to confirm everything they know about cometary physics. And what they see is nothing. The images that emerge are stark, haunting, and profoundly wrong. There is no glorious, hazy coma. There is no magnificent tail. Where there should be a brilliant, messy spectacle of gas and dust, there is only a single, sharp pinpoint of cold, indifferent light. The report from the project describes Atlas simply as a compact source of light, a description so clinical it betrays the shockwave it sent through the community. This wasn't just a lack of evidence, it was evidence of a lack. The defining signature of a comet was completely, inexplicably absent. But the real shock came when they compared these new images to the last good look we got, from the legendary Hubble Space Telescope back in July 2025. You see, an object that is accelerating, supposedly due to outgassing, is in the process of violently tearing itself apart. It is hemorrhaging mass on a cosmic scale. Based on its observed acceleration, Atlas should have lost at least 13% of its total mass, a staggering 5 billion tons of matter. An object that loses that much of itself should look fundamentally different. It should be dimmer, perhaps, or have a visibly smaller core. Its surface should be scarred and changed. Yet when the two images taken months apart were laid side by side, they were virtually identical. Atlas's appearance had barely shifted. This is the equivalent of watching a lit stick of dynamite, hearing the fuse sizzle, feeling the ground shake from its force, but looking back and seeing the dynamite stick perfectly intact, as if nothing happened. The effect, the acceleration, is there. The observable cause, the massive visible explosion of gas and dust, is not. This single discrepancy, this impossible observation, is the thread that begins to unravel everything we thought we knew. It transforms Atlas from a curious visitor into a profound physical paradox. It is an enigma wrapped in a mystery, traveling silently through our solar system, and its very existence is a challenge to our understanding of the cosmos. For centuries, our understanding of the solar system has been built on a foundation of beautiful, predictable mathematics. We live in a gravity well orchestrated by the sun. Planets, asteroids, comets. They all follow paths dictated by Sir Isaac Newton's laws of universal gravitation, later refined by Einstein's general relativity. It is a celestial ballet, and we have learned the choreography so well that we can predict the positions of planets decades, even centuries, into the future. It is how we land rovers on Mars and send probes to the outer reaches of the solar system. We trust in gravity. It is the ultimate rule. On October 29, 2025, as it neared its closest point to the Sun, Atlas broke that rule. The report came from NASA's Jet Propulsion Laboratory, JPL, in Pasadena, California, the nerve center for navigating our interplanetary spacecraft. These are the people who live and breathe orbital mechanics. When they say something is off its path, it's not a guess, it's a mathematical certainty. Their report was precise and deeply unsettling. Atlas's actual position had deviated from its predicted gravity-only orbit by 4 arcseconds. Now, 4 arcseconds sounds infinitesimally small. An arcsecond is 1/3600th of a degree. To put that in perspective, hold a pin at arm's length. The diameter of the pin's head is about 300 arcseconds. So, 4 arcseconds is a tiny fraction of that. But in the vastness of space, tiny angles translate to colossal distances. At Atlas's distance of 203 million kilometers from the Sun, a 4 arcsecond deviation is not a minor rounding error. It is a screaming anomaly. It is the equivalent of an Olympic archer aiming at a target 100 miles away and missing not by inches, but by the length of a football field. It means the object had been actively pushed, shoved out of its gravitational cradle by an unseen, persistent force. Let's break down that push. The data showed Atlas is accelerating at a rate of 0.2 millimeters per second squared. That's a whisper-gentle acceleration, a force so subtle you wouldn't feel it. But in the frictionless vacuum of space, over time, that whisper becomes a roar. It is enough to displace an object weighing 33 billion tons by more than 80 kilometers in just 1 month. Imagine trying to move a mountain range, not with dynamite, but by consistently blowing on it. Over a month, you've shifted it by 50 miles. That's the scale of the force we are witnessing. But here is where it gets truly bizarre. The acceleration wasn't a simple, straightforward push away from the Sun, as you might expect from outgassing. The JPL data revealed something far more complex. A two-directional thrust. There was an outward push, away from the Sun, at a rate that would shift it about 60 kilometers per month. But simultaneously, there was a sideways push, a lateral thrust, moving it about 270 kilometers per month. Think about that. This isn't just an object being pushed from behind. It's like a boat on a calm lake, with no sails and no visible motor. That is not only moving forward but also sliding perfectly sideways at the same time. Natural outgassing from a spinning, uneven comet core can be chaotic, producing thrust in multiple directions. But the sustained, consistent nature of this dual acceleration is highly unusual. It hints at something more controlled, more deliberate. NASA, in its official communications, was quick to reassure the public that Atlas poses no threat to Earth. Its lopsided orbit is not aimed at us. But this reassurance, while welcome, completely misses the point that has scientists losing sleep. The question isn't where it's going, but why it's moving that way. An object has entered our home, the solar system, and it is not playing by the house rules. It is no longer a passive ball of rock and ice coasting on the currents of gravity. Something else is acting on it. An invisible engine has been switched on, and we have absolutely no idea what it is. To understand the sheer magnitude of the problem Atlas presents, we need to turn to the world of basic physics, the kind of fundamental equations that govern everything from a thrown baseball to a rocket launch. This is where Dr. Avi Loeb, a Harvard astrophysicist known for his rigorous and often controversial thinking about interstellar objects, enters the story. Loeb doesn't deal in vague speculation. He deals in numbers. And the numbers he ran on Atlas produced a conclusion so stark, it leaves almost no room for a conventional explanation. The physics is beautifully simple. Newton's third law of motion. For every action, there is an equal and opposite reaction. This is the principle of thrust. To move a rocket up, you must shoot hot gas down. To accelerate a 33 billion-ton interstellar object through space, you must expel a colossal amount of its own mass in the opposite direction. It's a cosmic equation. We can see the acceleration, the reaction, so we can calculate the force required to create it, the action. Loeb did just that. He took the known acceleration from JPL-S data and the estimated mass of Atlas, a conservative minimum of 33 billion tons, making it thousands of times heavier than Oumuamua or Borisov. Its core is estimated to be nearly 6 kilometers across, the size of a small mountain. When you plug these massive numbers into the equation, the result is breathtaking. To generate the observed non-gravitational thrust through natural outgassing, Atlas would have to lose at least 1/6 of its entire mass during its trip around the Sun. That's a minimum of 5 billion tons of gas and dust. Let's pause and try to wrap our heads around that number. 5 billion tons. The Great Pyramid of Giza weighs about 6 million tons. So Atlas would have to expel the mass equivalent of nearly 850 Great Pyramids, turning it from solid into gas and blasting it into space. This wouldn't be a gentle, subtle process. It would be a cataclysmic, continuous eruption on a scale that dwarfs any volcanic eruption in Earth's history. It would be the single most spectacular cometary display ever witnessed in the solar system. And what would that look like? That 5 billion tons of gas and dust wouldn't just vanish. It would form that huge, glowing coma and tail we talked about. But we're not talking about a faint, fuzzy haze visible only to powerful telescopes. A cloud of this magnitude would be so vast and so brilliantly illuminated by the sun that it would be almost impossible to miss. It would create a shimmering, ethereal nebula around Atlas, a glorious beacon announcing its presence. From Earth, it would likely be one of the brightest comets ever seen, a new temporary star in our night sky. This is the critical junction where two undeniable sets of data collide head-on, creating a scientific paradox. Fact 1 from JPL's orbital data. Atlas is accelerating at a rate that requires it to have expelled 5 billion tons of material. This is a mathematical necessity based on the laws of motion. Fact 2 from the Virtual Telescope and Hubble images. Atlas is a clean, compact point of light, showing absolutely no evidence of this gigantic gas cloud. This is an observational certainty. Both of these facts cannot be true if Atlas is a natural comet. It's like finding a car that has traveled 500 miles but seeing that its fuel tank is still completely full. The journey happened, but the fuel was never used. This is the impossible equation. The visual evidence mercilessly invalidates the only natural explanation we have for the physical motion. This leaves us standing at a profound fork in the road. Either our understanding of physics is fundamentally wrong, or Atlas is not what it seems. And as Dr. Loeb argues, when the data doesn't fit the theory, you can't just throw out the data because it's inconvenient. You must consider other theories, even the ones that feel uncomfortable. The lack of that 5 billion-ton cloud is not a missing piece of the puzzle. It is a giant glowing sign pointing us towards a radical conclusion, that the force-moving Atlas may not be natural at all. If the mysterious acceleration and the missing gas cloud were the only odd things about Atlas, it would still be one of the most baffling objects ever observed. But they are just the beginning. As scientists have dug deeper into the data, a picture has emerged of a celestial body that seems to break the rules at every turn. It's not just one anomaly. It's a cascade of them, a series of irrational phenomena that, when taken together, paint a portrait of something utterly alien to our experience. Let's walk through them, one by one. Anomaly. 1. The impossible path. Imagine the solar system is a flat vinyl record, with the sun at the center and the planets orbiting in the grooves. This flat plane is called the ecliptic. An object falling in from interstellar space should, by all statistical probability, come in from a random direction, from above the record, below it, or at any steep angle. The first interstellar object, Oumuamua, did just that, coming in at a sharp 60-degree angle. Borisov came in at 44 degrees. But Atlas? It is traveling on an orbit tilted just 5 degrees to the ecliptic. It is sliding into our solar system almost perfectly parallel to the plane of the planets. The statistical chance of this happening randomly is practically zero. It is like throwing a dart from across a stadium with your eyes closed and having it land perfectly flat on the bullseye's surface, not just hitting it. Some theorists argue this isn't a coincidence, but a clue, suggesting an orbital insertion so precise it could be the result of purposeful navigation. Anomaly 2. The physics-defying jet. In the summer of 2025, observations revealed something that made physicists do a double-take. Atlas produced a jet of material that shot straight toward the sun. This is a complete and total violation of everything we know about cometary physics. The sun exerts two primary forces on cometary debris, the solar wind and radiation pressure. Both always, without exception, push material away from the sun, creating the tail. Atlas's sunward jet is like running into a hurricane and having your hair fly forward, into the wind. Some plasma physicists have tentatively suggested this could only be possible with an incredibly powerful, localized magnetic field on the object, one capable of overpowering the sun's forces, or more speculatively, a form of plasma-driven propulsion, an advanced technology similar to the ion engines we use on our probes, but on an unimaginable scale. Anomaly 3. The size and speed paradox. In astrophysics, size and speed are often inversely related when it comes to escaping a star system. Smaller objects, being more weakly bound by gravity, are easier to fling out into interstellar space at high speeds. Atlas is 1,000,000 times more massive than Oumuamua, and 1,000 times more massive than Borisov. It is a behemoth. Yet it is still moving at an incredible velocity. It breaks the rule that larger objects should move more slowly. It's like seeing a cruise ship winning a race against a speedboat. How does an object the size of a mountain achieve such a high ejection speed from its home star system? Advanced theoretical models offer speculative answers, like antimatter propulsion or directed photon energy, but these concepts exist for us only on blackboards and in science fiction. Anomaly 4. Perfect timing and a planetary tour. Look at Atlas's trajectory. It's a grand tour of the solar system. It coincidentally passed by Mars, Venus, and is on a course to approach Jupiter in 2026. Yet, during its perihelion, its closest approach to the Sun, the moment it should be at its brightest and easiest for us to observe, it will be positioned in a way that avoids a close pass with Earth. This intricate timing, This planetary flyby sequence is rarer than winning the lottery. It has led some researchers to whisper that this path doesn't look random. It looks like a pre-calculated route, like a probe sent to collect data on our solar system's major planets, while deliberately avoiding direct, close contact with our own. Anomaly 5. A man-made metallic signature. When we analyze the light from a celestial object, we can determine its chemical composition. This spectroscopic analysis of Atlas revealed something shocking. It contains more nickel than iron. This ratio is extremely rare in natural objects like asteroids and comets, which typically have a random mix of minerals. But where is this nickel-heavy ratio common? Here on Earth, in high performance, man-made alloys like Inconel or pneumonic, which are specifically designed to withstand extreme temperatures and stresses in jet engines and spacecraft hulls. This similarity is so striking, it raises the suspicion that the material making up Atlas may have undergone industrial processing or refining, rather than forming randomly in a protoplanetary disk. Anomaly 6. The absurdly dry property. Comets are called dirty snowballs for a reason. They are typically 80–90% water ice by mass. Yet, infrared spectral analysis of Atlas has found almost no signs of water or water vapor, even as it gets baked by the sun. It is estimated to contain only 4% water, making it drier than the most arid deserts on Earth. This profound lack of water has led many experts to question if it is a comet at all. To explain this, some have proposed that its surface might be coated in a protective layer, perhaps a refractory ceramic or a composite material designed to prevent evaporation. If true, this would be direct evidence of an artificial shell, a feature never before seen in any natural object. Anomaly 7. A unique fingerprint of light. Light can be polarized, meaning its waves are oriented in a specific direction. The way a surface reflects light gives it a unique polarization signature. Every natural object ever observed, from planets to asteroids to other comets like Borisov, has a signature that fits within a known range, characteristic of rough, uneven natural surfaces. Atlas's light is polarized in a way that has never been recorded before. It doesn't match any known natural object. Instead, in-depth analysis suggests its polarization pattern is eerily similar to light reflecting off a smooth metallic surface or a flat, structured object with defined angles, like reflective panels, or a symmetrical geometric structure. Anomaly 8. An echo from the greatest mystery. In 1977, the Big Ear radio telescope in Ohio detected a powerful 72-second-long narrow-band radio signal from deep space. It was so unusual the astronomer on duty, Jerry Eman, circled it on the printout and wrote, "Wow," beside it. The "wow" signal has remained one of the greatest mysteries in the search for extraterrestrial intelligence. SETI, a one-time broadcast from an unknown source. Now, plot the arrival path of Atlas back through the stars. It originates from the exact same region of space where the WOW signal was recorded near the constellation Sagittarius. The probability of this being a mere coincidence is astronomically low, yet too precise to ignore. Some SETI researchers now theorize that Atlas could be related to the signal's origin. Perhaps it is the very object that sent it operating on a long cyclical orbit, or even a cosmic relay station designed to transmit information across the galaxy. Anomaly 9. Hotter than the sun. Perhaps the strangest and most inexplicable anomaly of all is Atlas's color. It shines with a brilliant, intense blue hue. In astrophysics, color is directly related to temperature. Cold objects glow red, hotter objects glow white, and then blue. For Atlas to be emitting this much blue light, its surface would have to be at a temperature exceeding 5800 Kelvin. That is the temperature of the surface of our Sun. It is simply physically impossible for a non-stellar object, a small dark body millions of miles from the Sun, to reach such an energy level. There is no known natural mechanism that can explain this. Barring some form of advanced, unknown technology capable of generating immense energy, this observation should not be possible. Taken individually, any one of these anomalies would make Atlas a subject of intense study. But taken together, they form an overwhelming body of evidence suggesting that we are dealing with something that falls far outside the category of a natural object. They compel us to ask the question we have, until now, confined to fiction. Are we observing a comet, or are we observing a machine? The clock is ticking. As we speak, Atlas is hurtling through the inner solar system, on a trajectory that will bring it to its closest point to Earth on December 19th. This date is not just another celestial event to be marked on an astronomer's calendar. It has become something more. It is being spoken of in quiet, excited tones in university hallways and NASA laboratories as a day of reckoning, a potential turning point in human history. The entire scientific world is mobilizing for this single event, and the stakes could not be higher. Imagine an armada of observational power, the culmination of all our efforts to see into the cosmos, all turning to focus on a single point in the sky. The Hubble Space Telescope, our venerable eye in orbit, will be trained on it. The James Webb Space Telescope, with its unparalleled infrared sensitivity, will stare into its heart, searching for the heat signatures of propulsion and the chemical fingerprints of its composition. On the ground, dozens of the world's most powerful telescopes, from the deserts of Chile to the mountains of Hawaii, will coordinate their observations, capturing every photon of light they can. This is not a passive observation. It is an interrogation. And there is one question that every single one of these instruments will be asking: where is the cloud? The physics, as we've discussed, is brutally clear and unforgiving. If Atlas's bizarre acceleration is caused by natural outgassing, then 5 billion tons of its mass must have been converted into a gigantic cloud of gas and dust. This cloud is not optional. It is not a theoretical possibility. It is a physical requirement. Without it, the natural explanation completely and utterly fails.
So, on December 19th, and in the weeks that follow, we will be looking for this cloud. If we see it, if our telescopes detect a vast, hazy coma and a tail, even a faint one that somehow evaded previous detection, then the debate will shift dramatically. Atlas would be reclassified as a bizarre, but ultimately natural, dark comet. One with highly unusual properties that will rewrite textbooks but keep our worldview intact. Science would breathe a collective sigh of relief. The universe would be a little weirder than we thought, but still comfortably devoid of intelligence other than our own. But what if we don't? What if, under the combined, relentless gaze of humanity's most powerful eyes, Atlas remains as it has been? A stark, clean, compact point of light, moving under its own impossible power. If there is no sign of that gas, the whole cometary theory will fall apart, not just for Atlas, but it will cast a long shadow back on Oumuamua, which also exhibited non-gravitational acceleration without a visible coma. The conversation will be forced out of the realm of fringe theory and into the mainstream. The absence of the cloud would become the most profound scientific discovery of our time, because an absence of evidence, in this case, is evidence of absence. It would be positive proof that the force moving Atlas is not outgassing. And what are we left with then? We would be looking at direct, empirical evidence of a technology that does not belong to Earth. A propulsion system that operates outside the known laws of physics as we understand them. Something that might be moving with purpose, on a calculated trajectory, using a power source we can't even begin to imagine. The conversation would shift from, what kind of comet is it? To, what kind of engine does it have? And who sent it? The December 19th event is more than just an observation. It's a binary test. The result will be a 0 or a 1. And if that result is a 0, no cloud, then the implications will echo through every aspect of human civilization, from science and religion to philosophy, and our very sense of self. The countdown has begun. As the day of the verdict approaches, the official scientific discourse remains cautious, grounded in data and peer-reviewed analysis. But beyond the formal papers and press conferences, in the underground forums, late-night university debates, and private conversations, more daring and unsettling theories are beginning to take shape. Because sometimes, the most frightening thing about an unknown object is not what we see, but the possibilities hidden in what we don't. Atlas is silent. It does not broadcast any signals we can detect, but its silence is deafening, leaving a void that human curiosity and fear are rushing to fill. Some scientists speculate that its apparent simplicity might be a form of camouflage. Could it be concealing sophisticated observation or communication mechanisms that operate only in frequency bands we have not yet learned to monitor? The theory of the pre-calculated planetary tour has been taken a step further. Perhaps it isn't just a passive scan. Perhaps it is actively testing our solar system, probing gravitational fields, sampling the solar wind, maybe even searching for the technological signatures of our own civilization. A more shocking theory, one spreading through the darker corners of the web, is being called the mirror galaxy effect. It posits that every time a civilization in the galaxy reaches a certain technological threshold, specifically the mastery of nuclear power and the ability to travel beyond their own atmosphere, an automated observation device is activated from interstellar space. Its purpose, to assess the threat level of that emerging civilization to the wider cosmic community. Atlas, according to this theory, may be that device, a silent, ancient gatekeeper here to watch us. The most daring predictions center on December 19th itself. When Atlas is at its closest point to Earth, its moment of maximum observability for us, could it be a trigger point for it as well? What if a synchronization signal is emitted? Not for us, but for somewhere else, deep in the star-dusted abyss from which it came. A signal that could mean anything. Target acquired. Civilization confirmed. Stage 2 initiated. Or perhaps it's just another step in a millennial-long exploration plan of an ancient, patient civilization. We simply don't know. And that uncertainty is perhaps the most unsettling part of all. For now, Atlas remains a ghost in the machine of our solar system, hurtling through the void at a rate we cannot explain. But if the theories of an interstellar technology are correct, then when we look up at the night sky, we are no longer just stargazers. We are being watched. And this time, we are the subjects of the research. So, what can we, as individuals living our daily lives, take away from this grand cosmic drama? The story of Atlas is not just about astronomy. It's a powerful lesson in intellectual honesty and the courage to confront inconvenient truths. The core of the scientific method, as Dr. Avi Loeb so rightly points out, is that you cannot dismiss data just because you don't have a theory to explain it. When reality conflicts with your beliefs, you must be willing to question your beliefs, not deny reality. How often in our own lives do we do the opposite? When a friend acts in a way that shatters our image of them, when a project at work fails despite our best efforts, when a personal belief is challenged by new evidence, our first instinct is often to reject the data. We make excuses. We rationalize. We dismiss the anomaly because it's easier than rebuilding our worldview. Atlas teaches us that growth and true understanding only come when we have the humility to say, the facts don't fit my model. My model must be wrong. The lesson is to embrace curiosity over certainty. When faced with the inexplicable, don't run from it. Investigate it. Ask the hard questions. Be willing to be wrong. Whether it's a mysterious object in the sky or a confusing situation in your own life, the path forward is not through denial, but through fearless inquiry. Atlas is forcing the entire scientific community to confront the limits of its knowledge. We, too, can use the anomalies in our lives as opportunities to expand our own understanding of ourselves and the world around us. The coming weeks will be some of the most exciting in the history of science. We stand on the verge of a discovery that could change everything. Or we will find a perfectly natural, if bizarre, explanation. Either way, the journey of discovery itself will have been worth it. So I have to ask you, what do you think is pushing Atlas? Are we on the brink of meeting a galactic neighbor? Or are we just witnessing a 1 in a billion natural wonder? And more importantly, what would it mean for your life, for your beliefs, for your future, if tomorrow we had definitive proof that we are not alone? Leave your thoughts in the comments below. I read every one of them, and I'm genuinely curious what you think. If you want to follow this incredible story as it unfolds, make sure you subscribe and turn on notifications for this channel. I'll be releasing follow-up videos the moment new data becomes available, especially after December 19th, when we get our best look yet at this interstellar visitor. The countdown has begun, and together, we'll witness what comes next.